Hello everyone, I am Dr. Venkateswara Rao. In the last video, we had gone through the problems based on pH concept. Now, we shall go through the calculation of pH when equal volumes of 2 or 3 solutions of known pH are mixed. Right. In this, there are two cases. Case 1 is case 1 when equal volumes of 2 solutions of known pH are mixed, then final volume is doubled and concentration of H plus or OH minus ion is halved. Okay, when equal volumes of 2 solutions of known pH are mixed, then final volume becomes doubled and concentration of H plus or OH minus ion is halved. Okay. You keep 2 points in your mind, that is, when equal volumes of 2 solutions of known pH are mixed, then final volume becomes doubled and concentration of H plus or OH minus ion is halved. Let me clear this statement with one example. Equal volumes of 2 solutions of pH 2, pH 3 are mixed, then calculate the final pH, Okay, already I told you that when equal volumes of 2 solutions of known pH are mixed, final volume becomes doubled and concentration of H plus ions or OH minus ion is halved. Okay, and the problem is equal volumes of 2 solutions of pH 2 and pH 3 are mixed, then calculate the final pH. Okay, so the calculation is here pH, one solution having the pH 2 means concentration of H plus ions is 10 power minus 2. We know that rule. And another solution of pH is 3. If pH 3, then concentration of H plus ions is 10 power minus 3. Okay, so what happens? Final volume becomes doubled and concentration of H plus ions or OH minus ions is halved. So total H plus ions is 10 power minus 2 plus 10 power minus 3 and it becomes halved. It becomes, and the concentration of H plus ion or OH minus ion is halved, that is halved 1 by 2. So, here 10 power minus 2, if we common the 10 power minus 2, if you take 10 power minus 2 common, then 1 plus 0.1 or 10 power minus 1 by 2. This can be written as 10 power minus 2, it is 10 power minus 1 means 0.1, 0.1 plus 1, 1.1, so 1.1 by 2, 1.1 by 2. So, 1.1 by 2 means it is 0.55 into 10 power minus 2, and this can be written as 55 into 10 power minus 4. We eliminate the decimal places, we eliminate the points by multiplying with multiplying with tens. Okay, so 10 power minus 2, and this becomes, and final concentration of H plus ions is 55 into 10 power minus 4. So, already I told you, if concentration of H plus ions is x into 10 power minus y, then pH is equal to y minus log x, y minus log x. So, 4 minus log 55, its value is 1.74, log 55 its value is 1.74. Then we subtract the 1.74 from 4, we get 2.26. Therefore, final pH is 2.26. Final pH is 2.26. But this calculation, and for this calculation we need to know the logarithmic value of 55 or something else. Okay, I repeat, to perform this calculation or to calculate this pH, we need to know the value, logarithmic value of 55 or something. To avoid this lengthy calculation, there is an alternative method is there. There is alternative method. Okay, I repeat, to avoid this lengthy calculation, there is alternative method. That method is that shortcut is, it is better to call it as shortcut. It is better to call as shortcut. That shortcut is, if the given two pHs are differed by 1 unit, if given two pH values are differed by 1 unit, I repeat, if the given two pH values are differed by 1 unit, then take the average pH and subtract 0.24 to get the final exact pH, right. Let me calculate through that shortcut, right. So, here the given two pHs are differed by 1 unit. Here the given two pHs are differed by 1 unit. In such case, take the average pH. So, average pH is 2 plus 3 by 2. So, it is 5 by 2. 5 by 2 means it is 2.5. Okay, it is 2.5. It is 2.5. Then subtract then average pH. After getting the average pH, then subtract 0.24 from this average pH. So, 2.5 minus 0.24, that gives 2.26. That gives 2.26. Okay, so that is the shortcut. So here the shortcut is when equal volumes of two solutions of known pH 2 and 3, then the final volume is doubled and concentration of H plus or OH minus ion is halved. And one more thing is that the thing that we should keep in our mind is that if the two given pHs are differed by 1 unit, then take the average and subtract 0.24 from that average pH. Then we get a final exact pH as calculated in this method. Okay, actually this method is lengthy, it is a lengthy calculation, and that is a shortcut. Okay, this shortcut is useful to you all. Okay, so keep this in your mind. And case 2, now let us go for case 2. And here is the case 2. Here is the case 2, that is when equal volumes of 3 solutions of known pH are mixed, then final volume becomes 3 times and concentration of H plus or OH minus ion is 1/3. Right, I repeat, when equal volumes of 3 solutions of known pH are mixed, then final volume becomes 3 times and concentration of H plus or OH minus ion is 1/3. Let me explain this case with one example. So example is equal volumes of 3 solutions of pH 1, pH 2 and pH 3 are mixed. Calculate the final pH. Okay, and what we know is that when equal volumes of 3 solutions of known pH are mixed, the final volume becomes 3 times and concentration of H plus or OH minus ion is 1/3. Okay, so here the problem is equal volumes of 3 solutions of pH 1, pH 2 and pH 3 are mixed. So let us calculate the final pH. Okay, so the first solution pH is pH 1, therefore that is then concentration of H plus ion is 10 power minus 1. And if pH 2, so and the second solution pH is 2, then concentration of H plus ions is 10 power minus 2. And for the third solution pH is 3, then concentration of H plus is 10 power minus 3. Okay, and what we know, the concentration of H plus or OH minus ion is 1/3. Okay, so final pH, so total H plus ions is equal, total concentration of H plus ions is 10 power minus 1 plus 10 power minus 2 plus 10 power minus 3 by, okay, actually what we know is the final concentration of H plus or OH minus ion is 1/3, that is 1/3. Okay, so let us take the 10 power minus 1 is common, then 1 10 power minus 1 it is 0.1, and if it is if you 10 power minus 1 common, so that here 10 power minus 2, 10 power minus 2 means 0.01 by 3 by 3. So here 10 power minus 1, whenever here you should keep one point in your mind, whenever if the concentration is less than 0.1, then the decimals can be neglected. So here we can neglect the 0.01 because 0.01 is less than 0.1. Okay, so 10 power minus 1 and 1 plus 0.1 means 1.1 by 3. So 1.3 divided by 3, that is 0.33. So that's that value is 0.366. 0.366 into 10 power minus 1. 0.366 into 10 power minus 1, and this we can write this as 366 into 10 power minus 4. 366 into 10 power minus 4. Okay, so this is the concentration of H plus ions, and it is in the form of x into 10 power minus y. So then we can calculate the pH as y minus, that is 4 minus log x, that is log 366, and log 366 is log 366 value is 2.56, and it gives the value 1.44. It gives 1.44, that comes out to be 1.44. So this calculation also this is also a lengthy calculation. This is also a lengthy calculation, but for this calculation we need to know the logarithmic value of 366. Is it possible to remember the logarithmic value of 366? No. So that's why there is to avoid this lengthy calculation, there is alternative method, that is it is better to call it as shortcut, right? So that shortcut is when the 3 pH, when the given 3 pH values are differed by 1 unit, then take the average, and subtract 0.54 and subtract 0.54 to get the exact final pH. Okay, so to get the final pH. So here the pH given pHs are 1, 2, 3. Okay, the average is 1 plus 2 plus 3 by 3. So that is 6 by 3, and it is 2, and it is 2. So average is 2, and what I told to you, then subtract 0.56, So final pH is 2 minus 0.56, that gives 1.44. So here the final pH that we get from the shortcut, and that we get final pH that we get from the conventional calculation are same. Okay, so we need to follow this shortcut to solve the problem instantaneously. We should use this shortcut, right? Okay, so what let me sum up this lecture. That is, in this lecture we calculated the pH of mixed solutions. That is, when calculation of pH when 2 or 3 equal volumes of solutions are mixed, then pH calculation, then what would be the pH? Okay, here there are two cases. Case 1 is equal volumes of two solutions of known pH. Then we can perform that, what happen, then final volume is doubled and concentration of H plus or OH minus ion is halved. Okay, and for that shortcut is take the, and if the given two pHs are differed by 1 unit, then take the average and subtract 0.24 from that average pH, then we get exact final pH. And the case 2 is when equal volumes of three solutions of known pH are mixed, then the final volume is 3 times and concentration of H plus or OH minus ion is 1/3. Okay, so for that shortcut is take the average of 3 pH values and subtract 0.56. If the given 3 pH values are differed by 1 unit, then take the average of 3 pH values, can take the average of 3 pH values and subtract 0.56. Okay, so this is the shortcut. Okay, I hope you all understand this. Thank you.